Guys, and welcome back to my YouTube channel. Today we're going to solve some questions under continuity of functions, under continuous functions. Okay, so this is a question. Here we are asked to find the values of lambda given f of x is continuous. So that is what we're to do in the first question. And in the second question, we are to find the values of k also given f of x is continuous. So let's take the first question solution. Let's take question 1. Okay, here we are to find the values of lambda, but as you can see, we have different ranges with different definitions. So that already tells us that our lambda will have different values. And here also we have different points of continuity. Here we can see that 0 and 0 are the points of continuities for the first, 1 and 1 is the point of continuity for the second case, and 3 is the point of continuity for the third case. Okay, so now let's start solving. We are going to take the first case. We are going to take the first definition and its range, that is 0 for x less than 0 and lambda for 0 less than or equal to x less than 1. So that is what we have for the first case. So let's just say step 1. Okay, so here this is our range and we are to find the values of lambda. Here we are to find the value of lambda. So as I earlier said, first you need to look for your point of continuity. As you can see, here we have x less than 0 and here x continues with x greater than or equal to 0 and x less than 1. So we can see that 0 is our point of continuity. So we are going to have the limit of f of x as x is below 0 is going to be equal to the limit of f of x as x goes above 0. Okay, so remember this is what we have to do, and this case is when the function is continuous. Remember we were told in the question said given that f of x is continuous, find the values of lambda. So here we can clearly see that. So we have already been told that f of x is continuous. So now let's find the value of lambda. So here from this formula we have limits of f of x as x goes below 0 is equal to the limit of f of x as x goes above 0. So from here we can see that in this first definition and its range, here we are seeing that x is going below 0 because x is less than 0, and in this second definition we can see that x goes above 0. So here we are just going to replace 0 with x in the different equations. So we are going to have 0 here. It's only 0 that is there, so it's going to be 0 equal to, oh sorry, let me just make things clearer. So we'll have our f of x as x goes below 0, this is the limit, is equal to simply 0 because we only have 0 here. And the second case, the limit of f of x as x goes above 0 is simply going to be lambda. If we had a complete equation, if there was an x in this equation, then we would have substituted 0 with the x, but here this is all we have, so we are just going to equate them simply, because here we have to equate them from this formula. So we'll simply have lambda equal to 0. So this is our first value of lambda. Okay, now let's go to step 2. Step 2, to find the second value of lambda from the second case. So we are done with these two. So now let's go with these two. Okay, so we're working with lambda. We're working with that. And we are also working with lambda square on x square for 1 less than or equal to x less than 3. Here again, we can see our point of continuity. Here x is below 1 and here x goes above 1. So 1 is our point of continuity. So from our formula again, we have the limit of f of x as x goes below 1 is equal to the limit of f of x as x goes above 1. So let's have this first one. We have limit of f of x as x goes below 1 is equal to. So here we can see that x is less than 1 in this definition. So there we have only lambda. So we are just going to put lambda. And our limit of f of x as x goes above 1 is lambda square on x square. Lambda square on x square. But remember, we have 1, so x is going to 1. So we have to replace our x with 1. So to further simplify this, we will have lambda square on 1, which is still lambda square. Remember, we are just to equate them, because from this formula we are to equate them. So we'll just have lambda equal to lambda squared, and let's just bring them to one side. So we'll have lambda squared minus lambda equal to 0. So this is what we have. So from here we can do something. We can factor out lambda. Let's do it. Lambda, so we will be left with lambda minus 1 equal to 0. As you can see from here, we are going to have two values of lambda from this. So we are going to have lambda equal to 0 and lambda minus 1 equal to 0. So we can see have lambda from here. We'll just send this way. Sends this way, so that is lambda equal to 1. So here we have two values of lambda, that is lambda equal to 0 or lambda equal to 1. Okay, this is it for the second step. Let's go to the third step, step 3. Here we are going to be working with this and these two. Okay, so let's write it down. So we are going to be working with lambda square on x squared for 1 and we are also going to be working with 0. Sorry, let me just take a quick peep. X greater than or equal to 3. So this is what we are working with. So from here again, we can see our point of continuity, because here x is below 3 and here x is above 3. So again, from the formula, the limit of f of x as x goes below 3 is equal to the limit of f of x as x goes above 3. So let's take the first one, the limit of f of x as x goes below 3. So here in this case, x is below 3 because we have x less than 3. So we are going to have this. So we'll have lambda squared divided by x squared. Remember, x is going below 3. So we are going to substitute x with 3. So from there we would have lambda squared on 3 squared, which is equal to, we have lambda squared on 9. Okay, that is that. Let's have the second case. The limit of f of x as x tends to positive 3. Okay, so we are going to have simply 0. So we would have 0. Okay, now from the formula, remember, from that formula, we need to equate them. So we would have lambda squared on 9 equal to 0. So here, if we just cross multiply, we'll have lambda squared equal to 0. 9 times 0 is 0. And if you take the square root on both sides, the square root of 0 is 0. So here we have 0. So in this last step, we have lambda equal to 0. So from here, from our first step, we had lambda equal to 0. So here we had lambda equal to 0. We had that in that equation from the first one. And here we had lambda equal to 0 or lambda equal to 1. So in this step 2, we had two values for lambda. Okay. And in the third step, we had lambda equal to 0. So we can just say that generally lambda is equal to 0. Okay, so that is that for this question. And okay, here we have a second question, this one. So if you like, you can try this at home. It's the same approach for the first question we had. This question we had, it's simply continuity. And remember, we use this formula, and this formula applies when the function given to you is continuous. So that's it for today, guys. Thanks for watching this video, and I will see you guys in the next video.